Hello everyone, hope you all are doing well. So in the previous lecture we have discussed about physical properties of soil. So today we are going to discuss topic 19, that is about chemical properties of soil. In the next lecture we will do biological properties of soil. So first of all, the first chemical property is inorganic matters of soil. Inorganic matters of soil. So here we will see aluminum, silicon, calcium, magnesium, iron, potassium, sodium, etc. Chief inorganic constituents of soil. They are chief inorganic constituents of soil. Besides this, we have got some soil also contain some organic constituents in small quantities. In small quantities we have got boron, copper, zinc, molybdenum. We have got molybdenum. This is molybdenum. We have got cobalt, iodine, fluorine, etc. So these are some inorganic matters in a small quantity. Then moving on to the second chemical property, that is organic matter. Organic matter in soil. So we should know that sandy soil have very low quantity, very poor organic matter, very poor inorganic matter, very poor, that is less than 1%. It is peaty soils. Peaty soils are rich in organic matter as high as 90%. Substances of organic origin. Organic matter constitutes of substances of organic origin, that is living or dead plants and animals. Organic origin, that can be living as well as dead, that is plants and animals. For example, you can give plants and animals. And organic components contain compound of CHO, carbon, hydrogen, oxygen, nitrogen, sulfur, etc. These are some of the organic constituents or organic components of soil. Now moving on to another property, that is colloidal property. Colloidal property. It is of two types. First of all, we have got mineral or clay colloids. Mineral or clay colloids. And the second, we have got organic or humus colloids. Organic or humus colloids. First we will discuss about mineral or clay colloids. These are formed mainly of silica and alumina. Alumina and silica. Formed mainly of alumina and silica. SiLiC, silica. Alumina and silica, and also Fe, iron, and combined water. This is what mineral colloid are mainly formed of: alumina, silica, iron. Moving on to organic or humus colloids. These are chiefly due to presence of humus. As you all know, humus contains organic matter. So from here it comes organic or humus colloids. Now moving on to the fourth property, that is soil reaction. So you all know soil is either neutral or acidic or basic. So we should know here what is buffer action of soil. Let me rub this. Soil reaction. Soil could be acidic, basic or neutral. And what is buffer capacity or buffer action of soil? Resistance to change in pH. It is resistance to change in pH. How soil prevents itself in changing pH? How soil stops the change in pH? So soil have a good buffering capacity. What soil have a good buffering capacity. Soils have good buffering capacity. And this ability of soil, that is good buffering capacity, is important in agriculture for. It is important in agriculture for number one, we have got stabilization of pH. That is, it protects plants and microorganisms from direct and adverse and injurious effect of sudden change in soil reaction. Protect plants and soil or soil animals or soil microorganism from adverse and injurious effect. From adverse and injurious effect. Injurious effect due to sudden change in soil reaction. That is why stabilization of pH is important, and that's what good buffering capacity enhances is stabilization of pH. And again we have got the second important is that amount of amendment necessary. Amount of, I hope you all understand it, I am rubbing it. Amount of amendments necessary to correct soil. Necessary to correct soil reaction. C is correct soil reaction. So when we have got greater buffering capacity, we need smaller amounts of amendments. Such as lime, sulfur to correct water amendments, lime and sulfur to correct acidity or alkalinity. So when we have got good buffering capacity, we will need less amount of amendments. Okay, that is where buffering capacity is important. So this was all about soil reaction, and these are the chemical properties of soil. I hope you all understand it. And one question was asked in previous years about soil colloids, so we will discuss here. What I did in this course is that the previous year questions, all the previous year questions are converted into topics. So you don't think that I am not discussing the questions. During the topics I am discussing all the questions. So you should keep notes of it, keep revising it, and that will be your Brahmastra for preparation. So soil colloids. What are soil colloids? These are most active constituent of soil. Most active constituent of soil, and it determines the physical and chemical properties, and it determines physical and chemical properties of soil. Though these are the most active constituent of soil, which determines the physical and chemical properties, and these are very small particles. that is 0.001 mm small. You can see how small these are. So these are of two types: organic soil colloids and inorganic soil colloids. So organic soil colloids mainly composed of humus, and that is the shape is complex amorphous. They are made up of CHO, that is carbon, hydrogen and oxygen. They are more dynamic, that is formed and destroyed more rapidly, that is formed and destroyed more rapidly. And their structure is not well known. They possess complex structure. And you can see it here, complex amorphous solid it is, or complex amorphous structure. So they are not well known. They are very complex structure. So this was all about organic soil colloids. Now moving on to inorganic soil colloids. They are mostly clay and have a crystalline structure. These are commonly made up of SiAi and SiANO, and they are relatively stable. They are relatively stable as compared to silica alumina, and they are relatively stable as compared to organic soil colloids, and they have definite and well-known complex structure. They have a definite structure which is well known. So this was all about inorganic colloids, and this was organic colloids. Organic colloids are humus, complex amorphous. Main constituents are CHO. They are dynamic, that is formed and destroyed more rapidly. Their complex structure, their definite structure, crystalline, clay, inorganic, silica, alumina, relatively stable. So this was all about soil colloids, and there was nothing more asked about chemical properties. So we are going to finish the topic here. In the next topic we will do biological properties of soil. So that's all for today. Any queries, do comment, press the like button if you like the video, do share and subscribe. Have a nice day. Thank you.